In this practice, we will calculate VO2max using Submaximal VO2 test. So Lucy ran on a treadmill and she got to these stages. So on the first stage, she was running at 5 miles per hour at 10% grade, and her steady heart rate was 145. On the second stage, she was running at 6 miles per hour, 12% grade, and her steady heart rate was 180. So we have this number. We can use these formulas. We can plug these numbers to these formulas to calculate her VO2. But there are 5 formulas. How do we decide which one we use? We need to look at the limitations here. Okay, so on the the limitation for the second formula, it says it's more accurate when the speed is higher than 5 miles per hour. So we know we are using this second formula. So let's start. For the first stage, her heart rate at this first stage is 145, and speed is 5 miles per hour. But you need to be careful because when we're using this formula, the unit for speed should be meter per minute. So we need to change the unit. So 1 miles per hour equals to 26.8 meter per minute. All right, so this is something that you will need to memorize. So 26.8. So we need to use 5 times 26.8. So we get 134. This is meter per minute. Okay, so we can use this number and then calculate the VO2 for the first stage using the formula. So it's 3.5 plus 0.2 times speed, 134, plus 0.9 times speed, again 134, times grade. Grade is 10%, right? 10% is 0.1, okay? So we get 42.36. All right, then let's calculate the second stage. Second stage, her heart rate was 180, her speed was 6, again, times 26.8. This gives us 160.8. Again, this is meter per minute. All right, so VO2 for the second stage should be 3.5. We are using the same formula, right? 0.2 times speed, 160.8, plus 0.9 times 160.8. Times grade. Grade is 12%. So 12% is 0.12. So this gives us 53.0264. Okay, so now we have 2 VO2s and 2 heart rates. And remember in the class, I say we assume that heart rate and VO2 has a linear relationship when we are using submaximal VO2 to calculate VO2max. So let's use this. Okay, so let's draw something like this. Okay, so the x-axis is the heart rate. The y-axis is VO2. Okay, so at the first stage, the heart rate was 145, and the VO2 was 42.36. This is what we calculated, right? And at the second stage, the heart rate was 180, and the VO2 was 53.0264. All right, so let's make the dots like this. Okay. All right, so the first dot here, this is the first stage. The second dot is the second stage. And when you see 2 dots, we want to connect them. All right, so let's draw a line and connect them together. All right, and this is a linear, right? This is a line. So when we are talking about linear relationship, we are looking at this line. So let's say when Lindsay is at her maximal heart rate, we know that in this situation, we should see her maximal VO2, right? So VO2max should be here. So the third dot here should have, we can get her VO2max. do we know her heart rate maximal heart rate? We can calculate it using her age. So we can calculate age predicted maximal heart rate. So maximal heart rate is 220 minus age, right? And then we know her age is 20. She's 20 years old. So her age predicted maximal heart rate should be 220 minus 20. It is 200. Now we know this is 200, right? Maximal heart rate is 200. Okay, so how do we calculate the VO2 max? This is the number we don't know, so let's give it x. Okay, so this is the number that we want to calculate. Remember I mentioned slope in the class. So what is slope? Slope is how steep. Okay, so if you see a surface, right, and then you want to know how steep it is, first thing you want to see is how tall it is, right? There's a mountain and you want to see how steep the mountain is. Of course, you see if this mountain is very high, it has a better chance to be really steep, right? So we look at how tall it is. But there is another factor. Another factor is the distance, right? So the distance here, if it is longer, right, it will be less steep. And if it is taller, right? If it is taller, you see, it will be steeper. Okay, so the height here is delta y because it's the difference between these two y points, right? On the y-axis, the 2 points on the y-axis. The distance is delta x. That's the 2 points on the x-axis. Okay, so slope is the ratio of height and distance. Distance. Okay, so remember this. Slope is the ratio of the height and distance. Now we can come back to look at the rate line here. If you look at the rate line, you see there are 2 sections, right? On the first section, if you look at the slope of the first section and the slope at the second section, if you think about how steep they are, you know they are the same, right? If you are climbing this surface, you know they are the same. They have the same steep, right? So their slope is the same. So we can use this to calculate the x. So how do we do that? Let's do this first. Let's write this down. Slope equals to delta y, delta x. Okay, so let's look at the first section. The first section we draw this, right? So we have the height. So how do we get the height? We have these 2 numbers, right? So this is the delta y, this is delta x. So delta y is the height. We have this 2 number. Of course, we can get the delta x by using these 2 numbers. 53.0264 minus 42.36. Okay, so this is the height. And then let's look at the distance. That's delta x. So we have this number and this number, right? So it's 180 minus 145. Okay, so let's look at the second section of this this line. So here we have this delta y and this delta x, right? So the same thing. Let's calculate the slope of this section. Okay, so the slope of this section. Let's see the height delta y. We have x and 53.0264. So x minus 53.0264 divided by delta x, right? Delta x will be 200 minus 180. 200 minus 180. All right, so what's the relationship between them? They should be the same, right? Because that's the slope. They have the same steep, right? They have the same slope. So we get this. Okay, So the only variable in this, unknown variable in this formula is the x. So the other variables are numbers. So we can just calculate it, right? So after we calculate it, we get the x. This is 59.17. So remember, we need to give it a unit. So it's milliliter per minute per kilogram. So this is the VO2 max for Lucy.